हेलो स्टूडेंट्स, आज मैं आपके लिए एक पजलिंग कॉन्सेप्ट लेकर के आया हूं। दो चार्जेस है, दोनों चार्जेस सेम है। वन चार्ज इज मूविंग लाइक दिस हॉरिजॉन्टली इन द एक्स डायरेक्शन एंड द अदर चार्ज इज मूविंग इन द वाई डायरेक्शन अपवर्ड्स, and I have to find the force between the two charges. अगर at this instant of time, if the distance between the two charges are, I have to find the force between the two charges. I may have to find force on this charge, and also I may have to find force on this charge. अगर आपको याद होगा, what is the force due to a single moving charge? According to Bayes-Watt law, we have the force due to the current carrying conductor. But from there, we can also find the magnetic force created by a moving charge on another charge, or we can find the magnetic field by a moving charge, just by from Bayes-Watt law. Bayes-Watt law directly gives the magnetic field due to a current carrying conductor. But from there, we can, by a little mathematics, we can also find the magnetic field due to a moving charge. So what's the magnetic field due to a moving charge? The magnetic field due to a moving charge is vector, that is mu 0 by 4 pi q, charge of the moving particle, v cross r divided by r cube. This is the formula. This is the formula for the magnetic field produced by a moving charge. So magnetic field will be produced by this charge here at the site of this charge, and this charge will also produce magnetic field here at this point. That we have to see. Will this moving charge produce a magnetic field here or not? Now, can you tell me what is the magnetic field produced by this charge here at this point? That will be B V cross R. R is downwards, V cross R is inwards. So the magnetic field created by this moving charge, which is moving in the x direction, will be in the minus z direction, inwards into the board. That is Bz will be equal to magnetic field by this charge on the site of this charge. That is mu 0 by 4 pi q Vr, because V and R are 90 to each other, Vr by R square. It will be Vr sine theta, but theta will be 90, so it will be QV by R square. यहाँ R रहेगा ऊपर, तो जब आप इसको एक्सपेंड करोगे, that will be Vr sine theta. R इसका यहाँ सब खत्म होकर के R square हो जाएगा नीचे, right? Okay. Now with the negative sign, of course, because the magnetic field will be in the minus z direction. This is the magnetic field produced in the minus z direction. And this magnetic field acts on this charge. So can you tell me what is the force on this charge? What is the force on this charge? The force will be F equal to Q V cross B. That will be F equal to Q V B, because the magnetic field is inwards, that is minus z direction. The velocity is upwards in the y direction. The angle between them is 90, so it will be QVB, and that will be Q. V is V. What is B? B is mu 0 by 4 pi QV by R square. So that will be force on this charge, on the lower charge. So let me say it is charge 1, it is charge 2. Okay? So force on 1 due to the second will be, that is mu 0 by 4 pi Q square V square by R square. This is the force. But can you tell me what is the direction of this force? The force direction is, it is V upwards, B is inwards, V cross B, that's in this direction. That is in this direction. F1, 2. You can find the direction. It is V upwards, B is inwards, V cross B करोगे तो ऐसे आएगा, इस direction में, minus x direction में आएगा, इस direction में आएगा. ठीक है, that is good. This is the force on first due to the second. Now let me find the force on the second due to the first. What will be the answer? The answer is, I will tell you, because this charge, when it moves and at a particular instant it passes this point, at this point the charge lies along the line, velocity line of the charge Q, this Q1. At this instant of time, this charge lies along the line along the line of velocity of the first charge. Therefore, the magnetic field produced by this charge will be 0. Magnetic field produced by charge 1 will be 0. Therefore, force on this will be 0. So F21 will be 0. As simple as that. This charge is moving like this. The charge is here. This charge is along the line of the velocity. Therefore, it will not produce any magnetic. This charge will not produce magnetic field here at the site of the second charge. Therefore, the force on this charge will be 0. Because the magnetic field expression is V cross R. Here, V cross R will be 0. Or you must know, when the point is along the line of the momentum of the charge or along the velocity of the charge, at that point the magnetic field due to that moving charge is 0. So ये तो anomaly हो गया. This is a trouble. That means Newton's third law is not valid. There is force on this charge, but there is no force on this charge. So that means Newton's third law is violated. It also leads to the violation of the conservation of momentum. So two laws have gone. Newton's third law is violated. Also, the conservation of linear movement is also violated. The momentum will not be conserved. So this is an anomaly. This is a challenge to the students that do physics. I ask the students to discuss, to figure it out with your teachers. And later you can write down the answers in the comment section. This is really an anomaly, a problem which has to be sorted out. So I request all the students and teachers to work on this problem and see where is the anomaly, where is the problem, where is this, how this can be figured out. So the next lecture I will discuss the whole thing, but in the meantime you please try to discuss this with your teachers so that we come to a right conclusion. Thank you.